Welcome to GIS Sub YouTube channel, and this is the first video of our YouTube channel. And in this channel, we will be discussing about from the beginning of the fundamentals to the advanced theories of remote sensing and GIS. The target audience is anyone who is interested in learning remote sensing and GIS, or a newcomer to remote sensing and GIS, or a university students are welcome. This is the content of the video series. We will be covering the fundamentals of remote sensing and sensors and platforms, digital image processing, then fundamentals of GIS, GPS and coordinate systems, the applications of GIS and GIS with Python, how the Python language can be integrated with the GIS, and much more practical sessions using ArcGIS, QGIS, NV, EDAS, and SNAP softwares. Okay, first of all, we will see what is remote sensing. Actually, remote sensing is a science and technology by which the characteristics of objects of interest in the Earth's surface can be identified, measured, or analyzed without directly contact, which means we can acquire information of the objects which are on the Earth's surfaces without direct or without physically contacting them. This is the process of remote sensing. For the process, there are a few elements as the energy source, atmosphere, target, sensor, and ground stations. From there, the interpretation and the final output for the different kind of applications. Now we can see one by one how they participate for the process of remote sensing. Energy source. The first requirement for remote sensing is to have an energy source which illuminates or provides electromagnetic energy to the target. So the first requirements to have the remote sensing is to have an energy source which produces electromagnetic radiation. Obviously, here it is the sun. The second one is the atmosphere. As the energy travels from its source to the target and then from target to the sensor through atmosphere. Here is the atmosphere. The electromagnetic radiation which is emitted from the energy source or the sun is coming to the target through the atmosphere. After hitting the target, the reflected waves or the reflected radiation also transmitted to the sensor through the atmosphere. So atmosphere is the media of transferring. Then interaction with the target. Once the energy transmitted to the target through the atmosphere, it interacts with the target depending on the properties of both target and radiation. Which means this target on the Earth's surface can be any object such as trees, buildings, cars, uh, water body or vegetation cover, anything. So each of these objects have its own properties of electromagnetic radiation or electromagnetic radiation properties. So when the incident waves hit the target, part of that radiation is absorbed by the target and rest of the radiation is emitted to the sensor. So the balance radiation is collected by the sensor, and then that reflected radiation includes unit patterns. After collecting data from the sensor, then the record data by the sensor. After the energy emitted from the target, sensor collect and record electromagnetic radiation. Which means after the reflected waves come to the sensor collect and store the reflected radiation on its memory. Then transmission, reception, processing. The energy recorded by the sensor has to be transmitted to the processing stations where the data processed into maps, which means the collected data by the sensor is again transmitted to the ground station where the data processing takes place. In here, the collected data were converted into understandable format, which means by processing and doing some interpretations and making final maps to particular applications to solve real world problems. And here is an additional communication satellite. It is used to when the sensor is out of range from the ground station. We can use this communication satellite to acquire the collected data from the sensor and transmit those sensor data to the ground station, which means this ground station has a specific coverage. When the sensor is out of its coverage, we can use these communications to collect data from the sensor and again transmit it to the ground station. Finally, the applications. Final element of the process, remote sensing data, reveal new informations or help to solve real world problems, which means we can use this interpreted, analyzed data to solve different problems in many sectors such as agriculture, forestry, disaster management, mineralogy, geology, and etc. And now we will see in brief who get the benefits and why do they use remote sensing. The first one is the geographer. Geographer is using remote sensing to map in the changes of the Earth's surface. We know that by time, the Earth's surfaces is subjected to changes. So geographer use remote sensing to map the changes of the Earth's surface. Then the urban planner is using this technology to monitor land use and morphology. Then the farmer can use the remote sensing to monitor growth of the crops. Suppose you have a large vegetation cover, and when you are out of the city, you can monitor your crops using remote sensing and monitor the healthiness, and you can do the relevant precautions to the vegetation where the health is low. So ship captain use this remote sensor to find the best route. We know that there are no roads in the sea, so we can use this satellite technology to find the best route. And hikers also use to this technology or GIS to find their destination, because most of the time the hikers are choosing remote areas, so they need to know where are they going, so they can use this technology. Then the geologists use this technology to find valuable minerals, which means they can use remote sensing to find ground anomalies where where is a vulnerability to form minerals. And environmentalists, they can use this technology to identify and follow pollutants. Suppose there is an oil leak in the ocean, and they can use this technology to track the oil leak path. So there are a lot of other applications also, but in this video we will be discussing up to here now. And in the next video we will discuss about the principle behind the remote sensing and electromagnetic radiation. Thank you very much for listening, and hope you have gained some idea of remote sensing and what is remote sensing is. Now you know what is remote sensing is. And if you like the content of the video, or if there is anything to be changed or corrected, please leave a comment in the comment box. And if you didn't subscribe yet, please subscribe the channel, then click the bell icon, then you can receive the videos when I upload. So thank you very much for listening. See you soon in the next video.